Muchas gracias. ¿Sí? Sí. Cuando tú...
Con este, ¿verdad? ¿Karina? Con este. Hablamos con él. Él habla de eso. Ok. Okay, so welcome back. We are ready to start for the last talk for today. Okay, so you have Professor Martin Castro Manzano from UPAEP CONICET, Mexico, and his talk is entitled Caramuel's Logistic and Square of Opposition.
Thank you. Thank you very much for being here. I would like to begin by saying that originally I sent 3 contributions for this Congress. One about a partially connective logic, and another about relevant logic. But at the end, I had to choose. I had to pick just one contribution, and I decided to show you this one. And I hope you like it. And this is not my area of expertise, but it is something I find interesting. So, having said that, today I would like to proceed in the following way. I'm going to give you a very short introduction in order to explain the goal of this contribution. Then I'm going to present Caramuel's syllogistic, which I call fuzzy syllogistic. Then I'm going to offer an interpretation of that syllogistic, and at the end I'm going to offer square of opposition. So Juan Caramel and Lobkowitz is an interesting person. He was an interesting person. He was a philosopher, a priest, a mathematician from Spain. And because of his contributions to mathematics in particular, he was also known as the Spanish Leibniz, but not the other way around. We don't say that Leibniz is the German Caramuel, right? But we say Caramuel is the Spanish Leibniz. But his contributions to logic and mathematics are very interesting. In particular, for example, his study of syllogistic is quite ingenious, and his relational logic is considered nowadays an original contribution. In this contribution, however, we are going just to present a fragment of his syllogistic. Then we are going to offer an interpretation of that fragment in the context of a fuzzy logic, and finally we are going to show a square of opposition. So let us begin with the first goal. We can start by saying that being fuzzy is analogous, that being fuzzy can be said in many ways. For example, typically we say that the main goal of fuzzy logic is to model vague information. And usually we do this by using imprecise predicate. For example, young in Janis young, or bold in Curtis bold, or cold in the water is cold. But on the other hand, in doing so, fuzzy logic encompasses a variety of semantics. For example, Fukasiewicz semantics, Gödel semantics, and so on and so forth. And what I find interesting is that these semantics and these tools go beyond an emphasis on predicates. So, for example, we can see that we can use some other sort of quantifiers that we can call fuzzy quantifiers. So the idea is that to claim that some logic or system is fuzzy depends on analogical reasons, and one of which is the inclusion of those quantifiers. So this can be further explained by showing that fuzzy syllogistic is a variant of syllogistic that uses fuzzy devices. And these fuzzy devices are the fuzzy quantifiers. And we can find different, or a variety of fuzzy quantifiers. For example, absolute quantifiers, proportional, exceptional, comparative, proportional, comparative, or similarity quantifiers. There are many proposals. And granted this general premise, we can point out different systems that have already used this sort of quantifiers. So, for example, we have one over here that makes use of diffusive quantifiers with exact limits, like this, between 30 and 50% or exact values. We also have the program defined by SADE, in which we have absolute and proportional quantifiers that are defined by fusing numbers. And we have more proposals. This is just a short list. But what I gather from this information is the following argument. Because of course there are many systems and proposals, but it seems that after making this quick review, it seems that it is a sufficient condition for granting a logic status of foresee the inclusion of those quantifiers. So the first argument would be more or less like this. If these systems and proposals can be considered bona fide fuzzy logics, and they are considered so by virtue of the inclusion of fuzzy quantifiers, then surely for any given logic it would be sufficient to include fuzzy quantifiers for it to be considered a fuzzy logic. And since Caramel syllogistic includes such fuzzy quantifiers, it would follow that Caramel syllogistic is a fuzzy logic. So I'm going to try to unpack premise 2. In Morales' Pseudopolitica Logica, Caramel addressed the logic of moral and legal arguments by offering a scale of natural language quantifiers that can be associated with certain levels of inferential strength or inferential force. And his idea was that in these sort of arguments, often less than all members of a given class are subjects of predication, and consequently, the conclusions of such arguments should be more or less probable. So, for example, what Caramel called the syllogismus juridicus, seu moralis, as usual, consists of a major premise, a minor premise, and a conclusion. So, for example, here we have an example of a moral syllogism, which goes more or less like this. Anyone who injures any persons with intent to kill them is guilty of murder and must be sentenced to death. Peter injured John with intent to kill him. Therefore, Peter is guilty of murder and must be sentenced to death. And Caramel suggests that the first premise, the major premise, is usually like a legal norm, whereas the second premise or the minor premise should be justified by a moral argument or by a moral syllogism. And for example, Caramel thinks that in order to justify a premise like the minor premise, we should perform a syllogism like the following. Rarely does anyone, almost no one, boast about a deadly crime they did not commit. Peter was bragging about having caused a serious injury to John, therefore it would be bold to believe that Peter did not commit a crime. And as you can see, Caramel uses these expressions like ra, pi, and die, or should I say ra, pi, and di, because I think this is Latin. And these abbreviations indicate the mood of the moral or legal syllogism. And Caramel offered a table of syllogisms along with their names and the strength of the conclusion. And this is the table. And as you can see, we have this will be the quantifier. This will be the name of the syllogism or the name of the mood. And this would be the strength of the conclusion. And in Spanish, in English, it would look more or less like this. So, for instance, we have a syllogism that is called Camille, and a Camille has an universal quantifier, and the way of concluding or the strength of the conclusion is actually true. For example, the magistri, the quantifier is half, and the conclusion would be equally likely, and so on and so forth. So we can put all these syllogisms in this table, and we can see that all of them have the structure of a regular syllogism with a major and a minor premise. And what is interesting is the relation between the quantifier and the conclusion. Okay, so up to this point, this will be my first goal, showing the fragment of this logic by Caramel. Now, we would like to give an interpretation for this logic. So let S be a Boolean of structure of this kind, where omega is a set of events, and this closed interval is a domain of allowed values. And let P be a classical probability function that satisfies common maxims. Now, since premise one of each mood is of this form, Q M is P, where Q is the quantifier, and we can interpret the major premise, for example, with this expression, which would say something like the probability of X being P given that X is N is equal to N, where N is in this domain. And since premise two is of each mood is always given, premise two will always be true. Then we can quickly prove this theorem over here. We would basically say that if the major premise has value N and the minor premise is true, then the conclusion should be at least equal to N. That would be the conclusion. And we can summarize this over here, and that would be, say, a fierce interpretation of Caramel syllogism. Right? Okay, so that would be the interpretation, given the previous theorem. Now, before we continue, of course, three objections might appear. One objection is the following. The choice of values is arbitrary. Welcome to arbitrary land, Martin, because you are choosing these values arbitrarily, right? And while it is true that I have chosen these values arbitrarily, it doesn't follow that they are random, because random and arbitrary are not synonyms. Actually, I have a reason why I use those values. I'm going to show you why. A second objection may be this one, that this proposal is really not interesting because syllogisms are limited to the value of the major premise because of the previous theorem. And we can say that not necessarily, because if we take as the premise two cases close to N but different from 1 or 0, say for example, N minus plus minus epsilon, being epsilon in this open interval, and a significance level defined like this, such that this happens, then we can allow other fuzzy modes or other fuzzy syllogisms for cases where premise 2 is not entirely true, but whose significance is sigma squared. So we can do other syllogisms, not only those. And a third objection may be this one, that what I have done is just a probabilistic interpretation, and probabilistic interpretation is not a fuzzy interpretation. And my response to this objection would be that while it is true that probabilistic interpretation is not identical to a fuzzy interpretation, it doesn't follow that it is not fuzzy, because it can be argued that the former is a subset of the lab. So, having answered those objections, we can finally move and see the square of opposition. Of course, granted that this syllogistic is a fuzzy syllogistic. And the structure of the square would be like this. And in that case, I have ordered the square by quantifier, but we can also order the same square by conclusion strength or by value. And here is why I pick these values. Because this square is not only a square of opposition, but it behaves also as a magic square. And So, for example, you can see that this over here, the sum of these values is 1.5. The sum of these values is also 1.5, and these values is also 1.5. So this would be, for example, the place of contradiction in this square. The contradiction would be when the contradictor is some 1.5, and contrariety is when the difference is equal to 0.7. And so alternation would look like this when the differences of so alterns are proportional to the inverse values, something like that. And at the end, this would be the structure of Caramuel's QC square. And just as a summary, we would see, for example, something like this. So, for example, a Camilli syllogism would imply a Placidy, in the sense that actually true implies more likely. Or, for example, actually true is contradictory against truth, and so on. And so that's basically all. So these were our goals. We tried to present a fragment of Caramuel's logic, and we argued that this fragment can be interpreted as a QC logic. And at the end, we offered a square opposition. So if these ideas are correct, they might support the claim that this fragment of Caramuel's logic is a bona fide QC logic that precedes the QC systems of the 20th century, and that, as has been said elsewhere, in logic, as in other areas of philosophy, some are born posthumously. And that is it. Thank you. Sorry for my English.
Okay, thank you very much, Martin, for your talk. Now we're going to have a few minutes for questions. Alex?
Hello, thank you for the talk. Could you go back to the slides where, yeah, these kind of slides. So the blue arrows of alternation, so it goes from one element to the other, right? For example, we have some alternation from Camilli to Massimo, right? The product. You mentioned that contradiction is when, so there's contradiction when the sum of the contradictories is equal to 1.5. Does that mean that we have a contradictory relation between 3 elements instead of 2?
Oh, yes, I understood the question. No, that only means that by following the line, we get the sum, but you are correct. We should not read this as having like Mujibit is contradictory with Magistri or contradictory with Pudic. It's only just between Pudic and Muy. The sum is just a way of writing it down, or just a way to show. But it's not that this is a contradiction between 3 elements.
So it's a contradiction between the two outermost.
Yes.
But you still use Magistri in the definition of the contradictory.
Yes, I wouldn't say it's a definition. I would, but we just say it's a way of showing how the values might look or may look, but it's not precisely a definition. But that's a very interesting question.
It's an observation rather than a definition.
Yeah, exactly. It's actually I think it says remark.
Yeah.
Mm-hmm.
Okay. Now, Julio?
Modern examples of fuzzy logics and probability reasoning somehow grade predicates. Degree of evidence, the strength of evidence, and you included some examples in statistics where this quantification has a mean and standard deviation. That's the okay. That's a natural way to do it.
Yeah.
But somehow, very early in the talk, you insisted in putting all the fuzziness in the quantifier. That looks odd. Why do that?
Right. Yes, what I try to say is that being fusy can be said in many ways, and typically the hegemonic way of talking about fusiness is about the predicates, because the predicates can be vague, so we can use fusy devices in order to understand those predicates. But I think that as we go on in the development of fusy logic, we have seen that we can also apply these fusy devices or these fusy interpretations into other elements of the statements. And in particular, I'm interested in the quantifiers, and I think we can interpret the quantifiers in a fusy way, quite similar as we understand predicates. I don't know if this answer is satisfying, but that's more or less.
Strange.
Okay. But, thank you.
So Ariel and then Steph.
Yeah, thank you for the lecture. It was very nice. Well, if you go back to this syllogisms, I originally having trouble with this. Yeah, with this discussion around frequentism versus whatever you like to take. So yeah, most of objections to frequentism is going from, well, if you take a measure of the set and you say, well, this is a measure, and you map it into a 0-1 interval, and you say that, and you conclude that it is more likely or less likely. Well, some people wouldn't like that. So do you think that Kermwell's possibility is a kind of frequentism or no?
My answer would be, I don't know. I don't know, actually, for two reasons. One, because Caramel, at least what I can gather from what I read from him, has no particular opinion about that. And the second, or the second part of my answer would be that I don't know, because I understand the epistemological issue behind the frequentist or non-frequentist interpretation of probability, but I would say I don't know because I haven't thought about it, because I really don't care about the particular way of interpreting. I know this is not a good answer, but what I'm trying to say is that I haven't considered it, simply because this is not my area of expertise, and this is not particularly a project that I'm invested in. So I have to think about it. So, I don't know. Again, I think that is not a very good answer, but I want to say that I'm not sure.
Well, thank you.
No, thanks for this.
Steph?
Thank you. Thank you very much for the talk. I really like the project of using these formal methods to talk about medieval logic. I'm impressed a bit more on what Alex was asking as well about the observation about contradiction, because I think I agree with Alex that to me intuitively it makes more sense to just look at the two things that are contradictory to each other and then say that the sum of these contradictories is equal to 1, because there seems to be some kind of intuition at play there that contradictories are how do you say, jointly exhaustive. So that's the whole thing, the whole interval needs to be covered by contradictories, whereas with contrarieties and subcontrarieties, maybe there needs to be some overlap or no overlap whatsoever.
But that's a nice observation, and probably you're not going to believe what I'm going to say. But yesterday at night, I was preparing these slides, and my original slide said equal to 1. And I don't know what was I thinking. And I said, no, but why 1 if I can see the 0.5 in the middle? So at night, I wrote 1.5. but the original slide says just 1. But you're right. You're right. It doesn't make really many sense to put it like 1.5. But thank you again for the observation. So,
Thank you.
Anyone else?
Thank you. Can we see the names of the modes?
sure.
Yeah, Camille, it seems like we have always high conclusion. And there are no negative premises yet. Camille, magister, there is no E or
No. These names are related to the tradition of using names for the syllogisms, but they are not related to the typical AI, I, E, O, so on. So that's why we have, for example, that one Budici or Mujibi, because they are like quite original names.
Okay.
They are not precisely related to the typical names.
Okay, then that's.
Anyone else? No, more questions? Yes, so in this case, once again, thank you very much.
Thank
for
you.
the talk.
Thank you.
So we are closing the session now, and we're starting tomorrow at 10 a.m. with the last session. Thank you very much for coming.